More people are flying than ever, and cameras and phones are all part of the trip, capturing unbelievable moments of danger.
Oh my God, the plane is on fire.
For the first time, we unpack the science of what's really going on in these caught-on-camera crises.
Brace for impact, brace for impact.
Revealing in forensic detail how and why flights turn deadly.
He was literally clinging to the air to stay airborne.
Unravelling secret stories from cockpit error to engine failure.
So we've just had an announcement that we've got an emergency landing.
From freak weather to meltdown on the runway.
Oh my God! It's crashed!
Oh my God.
Discover the surprising truth behind planes gone viral. Modern aircraft are worked hard. Over their lifetime, they fly 52.5 million miles. They're engineered to take massive stresses and strains. On takeoff, engine turbines spin at speeds of up to 10,000 revs a minute. On touchdown, huge pressure is put on hydraulics and landing gear. Large modern aircraft are made up of 4 million finely engineered parts. But sometimes just one slight fault in one small component can bring an entire flight to a dramatic end. Friday, 28th October 2016. American Airlines Flight 383 taxis to the runway at Chicago O'Hare en route to Miami.
There was nothing wrong with the aeroplane that the pilots could see, and at that moment there wasn't. So they lined up on the runway, got clearance to take off, and then advanced the power levers and set off down the runway to take off. Just shortly after that, there was a big bang. There was a raging conflagration underneath the wing, which was slowly consuming the wing itself. The flight deck crew couldn't see the conflagration outside.
The view from the cockpit is designed so you can see out the front. You quite often can't see back to see the wings, for example, from the cockpit.
The plane is on fire, and the pilot doesn't yet know it.
You have a lot of panicking passengers that are looking towards you, and you have to make sure that they can trust you and that they know that you're going to save their life.
The cabin crew can see what's necessary. They are legally in charge of you while you're on the aeroplane. They could see that if they didn't get people out fast, the fire would reach the fuselage and people would die.
It's up to the cabin crew to take action, even without orders from the cockpit. In a fire situation, there's 90 seconds to get everybody out.
Sometimes you can't wait for the captain's command, because if you can see there's danger already around you, if you know that you can evacuate off that aircraft, that's the first thing that you're going to do. So first of all, you're going to check out the outside conditions before you deploy the slide and open the door, because the last thing you want to do is put passengers in danger.
The right-hand doors would open directly onto the flames.
You still see time after time people evacuating with their bags, and that is just so dangerous. The only safe thing for you to do is to get off the aircraft, and what you're doing by getting your bag is effectively saying, my bag is more important than the lives of those people behind me.
All you can do is shout commands, and it's like, leave that, come this way. So hopefully they listen, and if they don't, basically you're allowed to just drag them and get them off board.
The 3 left side emergency chutes are deployed.
Oh my God, oh my God, oh my God.
Oh my God. Oh my God, oh my God, oh my God. Oh my freaking God.
Despite the inferno, some passengers run back to the plane to try and rescue their bags.
People think about their briefcase before their own life.
Miraculously, all 161 passengers and 9 crew get out of the flames alive. But how could a fire come from nowhere before the plane has even taken off? As the aircraft speeds down the runway, a massive bang rocks the plane. Passengers on the right side see a clear liquid gushing out of the wing. It can only be one thing: fuel leaking from the wing tanks. Split seconds later, the fire erupts. But what caused the fuel leak? Investigators suspect the right-hand engine. The Boeing 767 totes 2 General Electric turbofans, producing 25 tons of thrust at takeoff. Turbine discs suck air into the engine and compress it, each disc spinning faster as air moves deeper into the engine. The blade tips move at 767 miles an hour. Air mixes with fuel and ignites, jetting out of the back of the engine, pushing the plane forwards. After the crash, it was discovered one of these turbine discs had shot out of the engine at such high velocity, fragments landed right across the airport.
It's rotating at a phenomenally high RPM. And so the centrifugal force is huge, and this metal, very hot, burst out of the cage which is supposed to contain it and smashed through the wing. Now, the wing in all aeroplanes is where most of the fuel tanks are.
Pieces of turbine disc are found embedded in the roof of a UPS hangar half a mile from the runway. The fuel tanks, inches from the engine, didn't stand a chance. When they get the broken turbine disc back to the lab, what they find is shocking. When the disc was manufactured, tiny impurities crept into the metal. After thousands of cycles of heating and cooling, these caused metal fatigue. The disc loses its strength and disintegrates.
The weakness suddenly shows itself, and the disc tears itself apart with centrifugal force and blasts its way through the engine casing.
GE replaces all faulty discs on Boeing 767-300 planes. Every passenger jet gets a full overhaul every 4 to 5 years. But this was a mechanical failure that before the Chicago fire, no one knew they had to look for. With so many components, no one can be 100% sure which risks failure next. September the 30th, 2017, one of the biggest passenger planes in the world, the Airbus A380, is about to demonstrate how true this is. Air France Flight 66 is carrying 497 passengers from Paris to LA and is 37,000 feet over the Atlantic.
Once you've got outside the congested airspace, it gets a bit quieter on the radio, so you can use the autopilot, use the automatic system. It'll be quite a calm, quiet atmosphere. And basically just making sure everything's going to plan.
Passengers John Birkhead and Pamela Adams are on board.
We had just had our big meal. After the meal, John and I got up and stood next to the galley. We were stretching.
Just a regular transatlantic flight on one of the world's most comfortable aircraft.
Halfway through the flight, there's an almighty bang.
My first thought was we've hit a gaggle of geese. But then my brain said, wait a minute, not at 35,000 feet.
Air France 066 Super, Mayday.
I could see the flight attendant, and he looked over out the window, and he turned back and looked at me, and I noticed that all the blood drained right out of his face.
You know, you're looking at this thing that's just completely disintegrated. The front end had basically just come apart.
Well, I was trying to calm myself down, but my emotions started to overtake me, frankly.
Air France Flight 66 is travelling west over the North Atlantic. With one engine down, nearest landfall is Canada, over 200 miles away.
They will make an immediate diversion to the nearest airfield. There's no ifs, no buts. They follow a checklist. The top of the checklist is identify the nearest airfield, and they will go for it.
Captain came on board and said, we're diverting. And I could hear a certain tremor in his voice.
The massive A380 needs a long runway to safely land. The nearest strip is 90 minutes away, a Canadian Army base at Goose Bay.
That 90 minutes was harrowing, to say the least.
I was very, very worried at that point. You know, this could be it. This could be, our numbers up.
The pilot starts his final descent. Passengers assume the brace position.
It got increasingly more anxious and panicky on board. Some people having panic attacks, anxiety. You know, you could just hear the panic go through the aircraft. People were not breathing, and I was trying to help myself breathe. Holding on to John, my husband, buckled in, kind of waiting to see what was going to happen.
With only 3 engines, the pilot manages to land the huge plane. All 521 passengers and crew are unhurt. Investigators face 2 mysteries. Why did the engine disintegrate 7 miles above the ocean? And how did the plane survive? As they start to reconstruct what happened, every fragment of shrapnel is painstakingly collected. Shards of engine are found 95 miles away, on Palmyot Island in Greenland. Others are closer to home, embedded in the undercarriage and the wing. They realise this flight had an astonishingly lucky escape.
The engines themselves are typically underneath the wing, and of course the wing's a fuel tank, so you don't want things coming out of the engine at any speed or with any energy.
A few inches one way and the fragments would have punctured the fuel tank in the wing, causing a potentially catastrophic fire. A few inches the other and they would have penetrated the passenger cabin, at the very least making it instantly depressurise. The answer to why the engine came apart is still under investigation at a UK flight lab. The reason the plane survived? Blind luck.
You couldn't really hear people crying until we landed, and then people started emoting and crying and getting up and panicking.
Eventually, pictures of the engine started circulating. At that point, we realised really how lucky we'd been.
The chances of luck turning bad increase as planes age, and their maintenance history mounts up.
Engines on fire, engines on fire! Engines on fire, we're calling the fire rescue right now.
October the 29th, 2015. A Boeing 767 just about to take off at Fort Lauderdale, Florida.
Wings 119. Go ahead, sir. Hey, dynamic out of the left engine. It looks like it's leaking a lot of, I don't know if it's fuel or it's fluid leaking out of the left engine.
It's a pilot on a nearby plane who first notices Dynamic Flight 405 bound for Caracas, Venezuela, with 101 passengers on board, is leaking fuel.
Emergency, call the fire truck. Pleasure 9002.
The fire started. The pilot's instinctive next step is to think about the passengers and the safety of the passengers and crew. And so that's an immediate evacuation situation. Stop the aircraft dead there and get the people out.
The crew need to get the passengers off as quickly as possible.
Time is of the essence because the aircraft could go up in any second. So when we open them evacuation doors and we're getting the passengers off, we just want to do it as quickly as possible because it could be a matter of life and death.
The captain hasn't shut down the right-hand engine, and huge gusts of air blast the emergency chute. Some passengers get thrown off onto the tarmac. Thankfully, everyone on board escapes, although 21 people are hospitalised. Investigators know the problem begins with the fuel leak from the left-hand engine. To achieve takeoff speeds of 160 miles an hour, jet engines are hungry for fuel. They need about 4 litres a second, pumped from the main tanks. But now fuel is spilling out of the tanks, onto the wing, and the intensely hot engine.
Now jet fuel has some additives in it. It has an antifreeze in it, but also has a fire retardant in it. On this occasion, the heat was so intense, the jet fuel ignited, and that started a terrific fire, as we can see.
But where did the fuel come from? The fuel tanks themselves are intact. Following the fuel path through the engine, investigators discover the fuel pipe itself has become disconnected. This Boeing 767 had been in service for 29 years at the time of the accident, with no previous mechanical problems. Dynamic had leased the plane 3 months earlier and flown it for 240 air hours without any problems. But during that time, no one had performed maintenance on the fuel line, and for the preceding 2.5 years, the plane had been mothballed by its owners. It hadn't flown, but nor had it had the same level of maintenance of a plane in service. All aeroplanes go through several types of maintenance over their lifetime, ranging from a basic A check every 500 flying hours to a full D check about every 4 to 5 years, when every component is taken apart. This can cost more than $1 million. The Dynamic 767 was just coming up to its next D check. The investigation suggested the maintenance the fuel coupling needed had fallen through the cracks. Modern aircraft come with a multi-million-dollar price tag, but they can be brought down by one of their cheapest components, the humble washer. China Airlines Flight 120 from Taipei, Taiwan, has just made a routine landing at Okinawa Island, Japan. But just minutes after arriving at the gate, fire breaks out under the right wing. 157 passengers and 8 crew are still on board.
One of the major concerns for any pilot is a fire, be that in the air or on the ground. But when you see something like that go off, that does send a shiver down your spine, because you think that you have no control over that.
With fire raging, passengers scramble to escape down the emergency chutes. A have-a-go hero ground staff member tries to put out the flames with a handheld fire extinguisher, oblivious to his personal safety. The captain, Yu Chien-kuo, and First Officer Tseng Ta-wei are the only ones remaining on board. They scramble to release a cockpit window to escape.
If they decide they can't get back into the cabin because there's a fire or there's smoke, then you do have the emergency exit on most aircraft, which in the pilot's case is the windows. You've got windows you can open on either side, and then you've got a rope.
Just 3 minutes since the first spark, the first officer, hanging out of the cockpit window, is thrown 20 feet to the ground by the power of the explosion. The ground staff member who took on the fire on his own also gets out of harm's way. All passengers and crew escape safely. The Boeing 737 is one of the most dependable and best-selling aeroplanes in history, with over 1,250 in service at any one time. So what could have caused such a massive fuel leak after what appeared to be a routine landing? Investigators need to know what caused fuel to leak catastrophically from the left wing. As they examine the wreckage, they find a small hole about 1.5 inches long, punched into the wing. In the hole is a loose bolt. It's clearly come from part of the plane. But what part? The answer soon becomes clear. It's a bolt used to work the wing front slat mechanism. As a plane comes into land, the pilot extends slats on the front of the wing to increase lift and allow it to come in at a slower speed. After landing, the pilot releases them back into the wing. But over time, the bolt has come loose. The slat mechanism actually pushes it back through the fuel tank and the skin of the wing. And this was one occasion where being on the ground actually made things worse.
If you have a fuel leak when you're in the air, or even if you're dumping fuel, of course you've got the airflow that tends to take the fuel away from the aircraft. But of course in this case, it's on the ground, there's no airflow to take it away.
Investigators are still puzzled why the bolt on the slat mechanism had come loose. They then discover that during routine maintenance 6 weeks earlier, an engineer had tightened the slat bolts, but forgotten to replace the washer. This missing tiny component was to seal the fate of a $51 million plane. Emergency inspections were then ordered on all Boeing 737s. They revealed 4 other jets to have similar problems. The maintenance schedule was increased. One microscopic detail can have a catastrophic impact. Jet engines can be put out of action by FOD, or foreign object damage. The biggest culprit, bird strikes. But there are other, less obvious reasons for FOD disabling aircraft engines. 24th of June 2013, Manchester, England. A charter flight with 325 passengers on board lines up on the runway for the 9-hour flight to the Dominican Republic. The pilot has been given the all clear for takeoff and the engines are pushed to full throttle.
When we're taking off on a runway, lots of things are happening quickly. The idea is to accelerate the aircraft to a speed at which it becomes a flying machine and not a wheeled machine. And so it's quite a difficult transition, this.
The Airbus A380 burns about 800 gallons of fuel on takeoff, propelling 240 tons of metal skywards. At this moment, the engines are under massive stress.
During the takeoff procedure, you've got certain speeds you have to adhere to. The first speed you get to is something called V1, and that's the point at which, below that speed, you can stop safely on the runways. If you go through V1, you have to continue the takeoff, and the next speed you get to is called VR, and the R stands for rotate. So when you get to that speed, it's at that point that you pull back on the stick, or the side stick, and lift the nose into the air and get airborne.
And he's seeing the pressure and the revs and the temperatures of the gas turbines powering this aircraft, and making sure that when we're using maximum thrust in this way, or very high thrust, everything is okay.
But things are far from okay with this flight.
Did you see that? One of his engines went.
The aircraft has reached takeoff speed, 161 miles an hour. The pilot must abort, but this aircraft is rapidly running out of runway.
It's actually quite an intense manoeuvre, the rejected takeoff manoeuvre. So you're looking at really keeping the aircraft straight when the aircraft doesn't want to be straight anymore because it's lost an engine and wants to turn you off. You're looking to slow down as quickly as you can.
The pilot stops the aircraft careering off the runway by manoeuvring the tail rudder and cuts the speed by activating the wing spoilers. It's a close call, but a potential disaster is averted by some cool-headed quick thinking.
An uncontained engine failure is not something you want at any stage. On takeoff, obviously you're using higher power than you would normally do, so that's more likely to happen on takeoff.
When the starboard engine is examined, investigators quickly discover a damaged turbine blade. But it takes longer to work out just what has caused the damage. At takeoff, turbine blades spin close to 10,000 revs a minute, generating intense heat. To counter this heat, the blades are made of a nickel-based alloy coated with aluminium and titanium. The investigation detects microscopic sulfuric corrosion on several blades, causing one to weaken sufficiently to shatter during takeoff.
That caused the blade to fail, and that's now flying through the engine at high speed and creating massive damage. So this is like somebody firing a gun into an engine, almost.
One theory linked the sulfuric corrosion to dust from an Icelandic volcanic eruption that severely disrupted air travel in 2010. However, later tests conclude the corrosion is linked to more general atmospheric pollutants. They were sucked into the engine, weakening the turbine blade and causing it to fail. The fallout from Manchester was immense, with over 10,000 having rolled off Boeing's production lines. The 737 is the world's most popular aircraft. All 737s with the same type of engine are inspected, and any faulty turbine discs replaced. Metal fatigue and microscopic corrosion can be hard to detect. But even the most obvious problems can be overlooked if an airline's maintenance routine is slipshod. May the 24th, 2013, Heathrow, London. British Airways Flight 762 takes off, en route to Oslo, Norway. Minutes later, a passenger alerts a flight attendant to a problem. The cover of the left-hand engine has blown away. The crew quickly discover the right-hand engine has similar damage.
The first thing that the flight crew will be thinking about is how quickly can I land? And that is the decision. Not should I land, but how quickly can I land?
With 2 damaged engines, there's no time to dump fuel. The only option is to prepare for an immediate emergency landing at Heathrow.
Yes, people will be worried. Nobody wants to hear that there's a technical problem. Nobody wants to think that you're going to have to make an emergency landing. But we have to sometimes prepare for these events nevertheless.
You don't have time to worry about everything. You deal with the problem, you adopt the correct procedures, you do what you've been trained to do and get the aircraft on the ground.
The pilot radios air traffic control. Heathrow, one of the world's busiest airports, readies for an emergency landing. Hundreds of flights are diverted or put on hold.
You've got an aircraft out of place then, you've got an aircraft arriving when people weren't expecting it. So yeah, it's very disruptive for a whole range of reasons. So that's why these decisions are never taken lightly.
As BA 762 approaches the airport, phone footage reveals the right-hand engine is now on fire.
They can set up the aircraft for a single engine landing, but there's always that worry if you've had a fire and if you've got a fuel leak that it could get worse very quickly.
Fortunately, the damaged left-hand engine is still working, allowing the pilot to guide the Airbus A319 towards the runway. The stricken aircraft bangs down, blowing out a tyre. But 26 minutes after takeoff, all 75 passengers and 5 crew are able to evacuate the aircraft uninjured. The question accident investigators need to answer is why had the 2 engine cowlings failed so spectacularly?
So around every engine you'll have cowlings. Now these serve a number of purposes. Firstly, they're smooth, so they want the outside of the engine to be nice and aerodynamic, but also they're designed to hold any damage. So if an engine fails, the whole point is to keep anything that comes off, breaks loose, inside the engine.
Amazingly, the investigation team discover the fault lies not with the cowlings themselves, but that they've been left unlatched by the night maintenance crew. The team's report highlights poor scheduling and staff fatigue as contributing to the mistake. Furthermore, the failure to lock the cowlings isn't spotted during a ground crew inspection because the latches are obscured by the engine. But what causes the fire in the right-hand engine? On takeoff, fragments of the right side cowling flew off, crashing into the wing, rupturing a fuel pipe. Fuel immediately sprayed out onto the superheated engine, causing it to quickly ignite and catch fire. This near disaster at Europe's busiest airport was a wake-up call. The investigation recommended better scheduling of overnight maintenance, and that cowling latches should be painted luminous orange to make them more visible to ground staff crew. Most aircraft mechanical problems are caused by material wear and tear, compounded by poor maintenance. But when it comes to launching a new aircraft, faults may originate with design and manufacturing. Despite rigorous test flights, some problems only come to light after several years of service. The 4th of November 2010, a Qantas Airbus A380, a radically new supercarrier, takes off from Singapore to Sydney. Just 4 minutes into the flight, there's an enormous bang. Metal fragments are seen flying past passenger windows, and smoke billows out from under the wing. In the cockpit, emergency alarms indicate multiple system failure.
In exploding, it caused huge damage to the aircraft control systems. It knocked out some of the hydraulic systems. It knocked out a lot of the electrical systems. There was between 30 and 55 individual emergencies coming up on the display screen that the crew had to deal with.
Having an emergency in the air is not like in a car. You can't just stop and call the emergency services. You've got to just deal with what you've got.
Although the aircraft is shutting down all around them, it remains flying, giving the flight crew a fighting chance to work out just what's going on.
Very complex situation they were faced with, potentially catastrophic.
The flight crew are busy flying the aeroplane. That's the first thing that they have to do. So the rules are generally aviate, navigate, communicate. Communicating with the passengers is the lowest thing on the list, so they'd rather fly the aeroplane safely.
Emergency sensors indicate engines 1 and 4 are malfunctioning. Damaged landing flaps, hydraulic failure, braking systems down to 30% capacity, and all left side electrics are down.
There is nothing in the book which tell the crew how to deal with a situation like that, where just about everything, every system in the airplane has received damage.
But the pilot is determined to get this A380, the world's biggest passenger aircraft, back on the ground. To do that, he needs to lose weight, and fast.
You have to dump fuel, because if you don't, when you come into land, the mass of the aircraft is so great still that the landing gear is likely to have a technical failure. It's likely to break when you try to land the aircraft.
After 90 minutes of circling Singapore, the aircraft is still 50 tons heavier than the recommended landing weight. But the flight crew realise they need to get the disabled jet down, and soon.
Has he got enough hydraulics to get the wheels down? When he slows the airplane down, will it still fly because there's damage to the left wing aerodynamics? How slow can he go without falling out of the sky?
The captain begins the descent into Singapore.
They couldn't control the engine on the outboard, even though they tried to shut it down, cut fuel off to it. All the controls had been broken to it.
The aircraft has major failures to the braking, electrical and hydraulic systems. What's more, it's massively overweight to make a conventional landing. The big question is, can they slow it down when it hits the runway, or will it overshoot? It's a critical situation that pilot Steve Wright attempts to recreate in a flight simulator.
You can feel all of these factors building up, and you can actually feel your heart rate rising and the last 30 seconds before you land. I would describe it as like a cardio workout. That's how intense the last moments of landing are.
The emergency services are waiting at the airport, anticipating a catastrophe.
It's going to be a hard one.
The massive aircraft thumps down. 4 of its 22 tyres burst on impact.
What's going through his mind is whether this aircraft is going to stop on the runway.
They now have just 4,400 yards to keep the aircraft straight and slow it down.
They had to cane the brakes at a screamingly hot temperature, which meant there was a massive fire risk, that the brakes would spontaneously burst into flames and take the airplane with it.
The A380 is brought to a halt just 150 yards short of the runway perimeter. It's been a very close call.
Considering, you know, the damage it did, it was remarkable that that aeroplane was handled in such an orderly manner and not a soul got hurt.
This is what pilots aspire to, and this actually be put in the situation, put under all that stress, and come out doing it so well. This is a really good example of how it's done.
No Airbus A380 had suffered engine failure before. The aircraft was only put into service 2 years before this incident. So how could such a highly engineered modern plane suffer so many multiple errors? The investigators discover a turbine disc has exploded. Shards of hot metal fire into the wing, rupturing 2 fuel tanks and severing undercarriage hydraulics and electrical cabling. Over 300 components fail. But why had the turbine disc exploded? Investigators find a fatigue crack has developed inside an oil pipe. The cause? One simple drill hole was not centered during manufacture.
In modifying it so that it was going to fit perfectly, it was made, the actual metal tube was made thinner than it should have been.
During the intense pressure of takeoff, the thin walls of the pipe crack, releasing oil. This oil spills onto the superheated engine, causing it to ignite. During the subsequent fire, the turbine disc explodes, firing hot metal through the wing, fuel tanks, and other major components.
It was poor quality control.
This was a bit of a wake-up call to the aviation industry in terms of how do you cope with multiple failures on board the aeroplane, and how do we design the engines and the airframe that it's attached to so that we don't get this many failures in the event of a massive uncontained engine failure.
Qantas immediately grounds all its fleet of A380s. 45 of the suspect Rolls-Royce engines are taken out of service and modified. The aircraft that could so easily have crashed over Singapore did fly again, but only after a $150 million refit. Since the start of commercial flights in the 1920s, the aviation industry has constantly striven to improve the design of aircraft, eliminate human error, and iron out component failure and manufacturing defects. However, whatever precautions are taken, it seems mechanical failure can still strike without warning. But thanks to the efforts of designers, engineers and technicians, there are far fewer mechanical failures than ever before, and taking to the sky has never been safer.